So students, after studying about the parallel lines, now we will find out something about the indices and the cube root. Okay, so this third chapter is for indices, their rules and the cube roots. See, I know that last year you have studied about the laws of indices. Can you tell me what are the laws of indices and what is the first index? When a number is written in the form of a raised to m, then it is called as a number with index m. Here I know that a is called, so a is a number which is repeated, which is called as base, and of course the number which is written on the top of it, that is on its head, so it is of course known as the index or the power. Okay, both the way you can say. That is how to read this number, a to the power of m, like that also you can read, or a raised to m. Okay, both way you can read. And what is the meaning of this? That is, suppose for example we will take, that is 2 raised to 5. I will call it as 2 to the power of 5 or 2 raised to 5. And what is the meaning of it in our multiplication form? It is 2 into 2 into 2. How many times? I will write 5 times. Okay, so actually it is a shortcut method. By this shortcut method, can you write the multiplication of the numbers or the division of the numbers or any other type of numbers? Yes, and you have learned the laws of indices. Okay, so which are the laws of indices? Can we recall it? Okay, so which is the first law? And remember that these laws of indices are applicable for product or division or any number when the base is same. You cannot multiply with this law when the bases are different. That is 2 raised to 3 into 3 raised to 4. You cannot multiply like this. You have to find out the separate value and then only you can multiply. But the base is same. That is, suppose 2 raised to 3 into 2 raised to 4. Here index is different, but what is same? Base. And so I can write it as 2 raised to 3 plus 4, and that is of course 2 raised to 7. And which is this law? This is my first law of multiplication. I can write it a raised to m into a raised to n is equal to a raised to m plus n. So when you are going to multiply the two numbers with the common base, you can add the index. Okay, so this is the first simple rule. Then what about the division then? Suppose I say 2 raised to 5 divided by 2 raised to 4. Then when I want to divide it, I can subtract it. 5 minus 4, and that is equal to 2 raised to 1. 1 need not to be written. And so this is law, a raised to m divided by a raised to n is equal to a raised to m minus n. Multiplication, there is an addition of index. Division, there is a subtraction of indices. What about if there is a law 2 raised to m? So I am getting one example. So I will write here 2 raised to 2 raised to 3. Here there are 2 indices, and so I will write 2 raised to 2 into 3 and then 2 raised to 6. That is, when there are double index number, that is base is also a number with the index, then I can multiply them. And how I will write? A raised to m raised to n is equal to a raised to m into n. These are 3 fundamental laws. But besides that, if I want here, as I have written a base into a power itself, that is in base is also a number with some power or with some index. That similarly, if there can be two different numbers, that is here I will write again not the numbers but 2 into 3 raised to 4 suppose. So base is now not a single number but a multiplication of 2, then I can give this index separately for both. And see, here the bases are different, and so I cannot use this multiplication. But here this I will write it as a into b raised to m is equal to a raised to m into a raised to n. See here, though I have written only for two numbers, that is a into b, but it can be a into b into c into d into e, any number, okay? But the question is only there should be a multiplication sign, that is 2 into 3 into 4 into 5. Then also the same index should be given for each base. Similarly, again, when the multiplication is there, why not the division also, like 2 upon 3, okay? Then I will again write the same ratio, same index. How I will write? 2 raised to 4 upon 3 raised to 4. Here also I can write it as a upon b raised to m is equal to a raised to m upon b raised to m. Here not m but the same number, and I have to write a into b raised to m. See here, the first law again I will say a raised to m into a raised to n. The numbers with the same base, add the index. Number with the same base, subtract the index when division. Square, that is a power of a power. Then multiply both the powers. Then base in the form of multiplication, give same index for all the base values. Similarly, the difference. And here, after this 5, I know that there is some special value for a number which raised to 0. 3 raised to 0, 4 raised to 0, minus 5 raised to 0. Then anything raised to 0 will be equal to 1. And so here I will write it that this is a raised to 0 is equal to 1. A indicates any number, and so any number when raised to 0 is 0. This all we know. Only one small question about the negative index. So suppose I have written 3 raised to minus 2. Then I know minus 2 times how I will write 3. Minus 2 is not a counting number, and so I want to convert it into a counting number, then only I can find out its value. And so then I want to change its place, that is numerator into denominator. Here you can imagine that there is a denominator 1. So denominator will go to numerator and the numerator will go to denominator with change in size. Okay. Here I can again write this law as a raised to minus m is equal to a raised to m. And if it is ulta, then what it will be? A raised 1 upon a raised to minus 2. Change it, a raised to 2 upon 1. So it is that simple. This is applicable again in one place. That is when a upon b raised to minus m. What I will write? I want to change the place, that is numerator to denominator, denominator to numerator. So I will change b upon a, and now I can change its sign, minus m to plus m. So here also you can get one important note for that. Okay. So these are some indices. Here we have learned that these laws are true for m is a whole number or counting number, that is a natural number. But what about if the number, that is the index, is not a counting number but it is an integer. Integer means a fraction, not integer but a fraction. That is, suppose I write a raised to half. Now I know that a should be written half times. Is it that? Can you count half time? I can say one time, two time is okay. But what about half time? Then there must be some other meaning of this. Okay? So we have to learn the meaning of an index with a fraction. In that fraction, the number is in the form of, here I will give you the number, that is the index in the form of 1 upon n. See, what is the importance? Is 1 is a numerator. It is always 1. First we will find out if it is if it is other than 1, we will find out. But first let us take that numerator is 1 and the denominator is something counting number, that is 2, 3, 4, 5, 6 and so on. Okay. So then when it is 1 upon 2, you have learned this, that it is written as a square root of a. What do you mean by that? That is, suppose I write 5 raised to 2 is equal to 25. Okay? 5 raised to 2 is 25. That is square. Square of 5 is 25. And if I want an answer 5, then I will ask what is the square root of 25, and the square root of 25 here also I will write it as square root of 25. How I will write it? With this sign, square root of 25. This is a radical sign. This sign is known as a radical sign. Okay? Radical sign means it indicates the root. Root, radical is a root only. And say which root? If nothing is written, then it is a square root. If I write here cube root of 25, here it is 3. So cube root. And then I will write it as 25 raised to 1 upon 3. This I can write 25 raised to half. Now see, you can compare these roots. 25 raised to 1 upon 3. What does it mean? Cube root of 25. That is any number, of course you can take. Suppose I take 8 raised to 1 upon 3. Then what I will write? Here it is a cube root of 8. Okay. So now it is a cube root of 8. This a special name for when n is equal to 1 or 2. Okay, 2 or 3. If it is 2, we will call it square root. If it is 3, I will call it cube root. And what about? I write 5 raised to 1 upon 4. Then how I will read it? See, now n is 4. N is a denominator and its value is 4. It indicates the root, and so I will write here that 4th root of 5. Can you name now which root is given? Suppose I have given it is 1 upon 7, 2 raised to 1 upon 7. Then this is 7th root of. Only find out which is a number and give it a ordinal form. Then you will write it as 7th root of 2. If it is given ulta, can you write it into the index form? Suppose I want to write 5th root of 8. How you will write it? using the index form. With which root is it? 5. So it will go to the denominator 1 upon 5 of which number? 8. So I will write 8 raised to 1 upon 5. Okay. So this is how we will have a meaning for this. Suppose n is equal to 2 upon 3, then 1 upon n will be equal to 1 upon 2. We call it square root. Okay. If it is 1 upon 3 or then we call it cube root. But if it is 1 upon 4, then we will call it fourth root. If it is 1 upon 7, we will call it seventh root, and so on. If it is 20, then we will call it 28th root, and so on. Okay. Generally, in our standard, that is 8th standard, we need only square root and cube root. Square root we have learned in the last year, and you remember that if I write 16 raised to half, that is, I will convert it with the radical sign, 16 root, that is square root of 16, and I know it is 4. Why 4? Because I know when 4 square, it will give you 16. But 4 is the only number which square is 16? No, it is minus 4 also. It is also 16. Then how can you say that root 16 is plus 4 and not minus 4? Yes, I know this. Also you have learned that square roots are always having two numbers, that is positive and negative. Which number should be taken? We'll show you this sign, the sign of the square root. That is, again you can find out, if I have written square root of 25, then I will write it as 5. Why? Because the sign is positive. That means I need positive square root. If it is minus root of 25, then I will write minus 5. Okay? That is, it is a negative square root. That means each number has two square roots, each square numbers. All the non-square also have two roots only. That is, each number will have two roots, positive and negative. So which root should be used? Will be given by this sign, the sign of. And so I will say that root A gives the positive square root of A. And if it is written minus square root of A, then this is negative square root of A. Okay. So this is a meaning of this positive square root and negative square root. Now let us see how can we find out the cube root or its forms. Now we have learned the meaning of an index with a fraction. That is, I can write a number A with the fraction index, that is 1 upon n. So how I will explain this? That is the nth root of, so I will write here like this, nth root of A. Okay. So taking this into consideration, let us find out practice set 3.1 how the sums are asked. So the first sum is express the following numbers in index form. So whatever we have given in the written form, that is a sentence form, we want to write it in the index form. See, let us see. Fifth root of 13. So we will find out which root is there. Fifth root of which number? 13. So base is 13 and the fifth root, see here, the n is in the denominator, so 5 should also be in the denominator. So 13 raised to 1 upon 5. Next, sixth root, here also, of 9. So I will write here 9 raised to sixth root. So it is 1 upon 6. Okay. Square root of 256. Square is a special number having 2 index. So 256 raised to 1 upon 2. Then cube root of 17. Cube stands for 3. And so it is 17 raised to 1 upon 3. Now 8th root. See, whichever the number is there, we have to write in the denominator. So here it is 100 raised to 1 upon n. And the 7th root of 30. And so 30 raised to 1 upon 7. This is how we have written our first sum.